Today's lesson is going to be on statistics. We'll be covering stem and leaf plots and box and whisker plots. Before you view the lesson, be sure that you have already printed out your PowerPoint so you can take notes. Once you've done that, you're ready to begin. Before we can get into the lesson, we need to go over some vocabulary for statistics. Mean is the average. To find your average, you need to add all the numbers in the data set and then divide by the amount of numbers in your data set. Your median is the middle number in the data set when all of your numbers are arranged in order from least to greatest. Mode is your number in the data set that occurs most often, and remember, you can have more than one. Your range is your largest number in the data set minus the smallest number in your data set. And an outlier is a number that's far away from the majority of numbers in the data, and it usually will skew the mean. You will not necessarily have an outlier, but it is possible. So let's go on and talk about stem and leaf plots. So in a stem and leaf plot, you're going to have a stem and a leaf. The stem represents the first digit in a term, and that's usually going to be written first, or if you have a 3-column, it'll be in your center column, and we'll go over what those look like. Your numbers in the columns need to be in order from least to greatest, and they are going to be vertical. The leaves in your stem and leaf plot, they're going to be your second digit in the term. Again, they are in order from least to greatest, and they work from left to right. And if you have a stem and leaf plot that has more than one column, that might change. If a number occurs more than once, you need to write it more than one time. Okay? And your key, and sometimes it's called a legend, they mean the same thing, they're going to tell your reader the value of the numbers in the plot. So let's look at the next slide and put some of these vocabulary terms to use. Okay, so let's take a look at the stem and leaf plot that we've got in front of you. You'll see here that you have your data set. Okay, what we have done is we've taken the first digit in each one of the numbers in the data set and we've put them in the stem. Okay, so we've taken the 1 for 10, 15, and so on, and then the 2s, 3s, and 4s. We've taken the second digit in each data set and put them in the leaf column. We've arranged from least to greatest, and if the number occurs more than one time, we have written it more than one time. Now let's take a look at our key. Our key tells us that 3/1 is equal to 31. Okay, so again, 1 and 0 stands for 10. It's very important when you're creating a stem and leaf plot that you make sure that the number of leaves match the amount of original data. Okay, so you would count up 0, 0, 5, 0, 1, 1, 3, 1, 2, 4, 9. Count those up and make sure that they match all of the data in your original set. Okay, so looking at the stem and leaf plot that we had on the previous slide, now we're going to do some calculations with this information. So we need to find the mean. Again, that means the average. So what we would do is we would add up all of the numbers in our stem and leaf plot, and then we would divide by the amount given. Okay, so if we add 10 plus 10 plus 15 plus 20 plus 21 plus 21 plus 23 plus 31 plus 32 plus 44 plus 49, that is going to give us 276. We need to divide that by 11 because we have 11 leaves in our stem and leaf plot, and you will see that your mean is 25.09. Now the median is going to be the middle number. Okay, so when you're doing a stem and leaf plot, you're going to go crossing off from the least to the greatest, and you're going to find the middle number. Now, because we have an odd number in our data set, we can count off 5 on each side, and the middle number is going to be our median. So 1, 2, 3, 4, 5. So this will be our middle number. Double check. 1, 2, 3, 4, 5. So our median is going to be 21. Mode is the number that happens most often. Well, in this case, we have more than one. We had 10 that happened twice, and we also had 21 that happened twice. And then our range would have been, you have 49 minus 10, so our range is going to be 39. Okay, so now let's look at an example where we have a double column stem and leaf plot. When you have a double column stem and leaf plot, you're comparing something. So in this case, we're comparing cities mile per gallon and the highway miles per gallon. Let's take a look at our legend and find out what this means. When you look at the center column, we have 2. And this is telling us that 2, and looking at the right with the 7, means 27 miles per gallon. Then you've got the 2 in the center column and a 0 to the left, which means 20 miles per gallon. So that's just giving us an indication of what those numbers mean. So to find the mean for the city, we need to add 19 plus 20 plus 23 plus 23 plus 28 plus 29 plus 31 plus 31 plus 34. When we add all those numbers together, you get 238. We need to then divide by 9 because there's 9 sets of data for the city. That gives us 26.4 as a mean. From here, we need to find the median for the city. Now remember, you are crossing off from least to greatest. So 19 is our least. And we're crossing out 5 because we want our middle number, and we have an odd set of data. So, we're crossing out 4, excuse me. So we cross out 19, 20, 23, and 23. So we have 4 on each side of the median, meaning that our median here is 28. The mode is the number that happens most often. And this situation for the city, we have 23 and 31 that occurs twice. So both of those need to be listed. And the range is the highest mile per gallon minus the lowest. So we take 34 minus 19, which gives us a range of 15. Now let's take a look at the highway. We have to do the same thing for the highway. we don't have anything in the teens, so we're starting with 27 plus 28 plus 30 plus 32 plus 32 plus 37 plus 38 plus 38 plus 41. When we add all of those together, you get 303. Again, we're dividing by 9 because there's 9 pieces of data for highway. And that gives us an average of 33.7. Our median, which is our middle number, again, we're going from least to greatest. So we cross off 27, 28, 30, and 32. And that gives us a median of 32. Our mode, again, the numbers that happen most often, well, we've got 2. We've got 32 and we have 38 that are both occurring more than one time. And the range is 41 minus 27, which gives us a range of 14. So we're going to take this information, and on the next slide we're going to do some comparison with that. Okay, so let's take a minute and just transfer the information from the previous slide onto our current slide. So the city, we had 26.4, 28, 23, 31, and 15. For the highway, we had 33.7, 32, 32, and 38, and then 14. Okay, so the first question wants us to find the difference in the mean for the city and the highway. What does difference mean? Difference means subtraction. So we are subtracting our highest number, which is the highway, minus our city, and that is going to give us a difference of 7.3 miles per gallon. Then they want to find the average gas mileage for driving in the city and the highway. So what we're going to have to do there is say 26.4 plus 33.7 and divide it by 2. That's going to give us an average mile per gallon of 30. Now we're going to discuss box and whisker plots. Box and whisker plots is just another way to display a set of data so you can easily see where most of the numbers are. Okay, it's not going to list all of the numbers, but it is going to give you where most of the numbers fall. Your box and whisker plot is obviously separated into a box, which is listed in green, and whiskers, which is the line you see extending from either side of the box. Your box and whiskers are divided into 4 sections. Quartile 1 goes from the whisker to the beginning of the box. Quartile 2 goes from the beginning of the box to your median. Quartile 3 goes from the median to the end of the box, and quartile 4 goes from the end of the box to the end of your whisker. Each section, each quartile, represents 25% of your data. Now let's take a look down here at the actual box and whisker plot. Your minimum is the lowest number in your data set. Your maximum is the highest number in your data set. Your median is the middle number, And then to find your lower quartile range and your upper quartile range, you're going to take the median of the lower set of data and then the median of the upper. All right, so let's practice with this information. All right, so the slide that you see here is just giving you a step-by-step to follow when creating these box and whisker plots by hand. First thing you have to do is write your data in order from least to greatest. You need to be sure that the number line that you draw includes all of the numbers in your data. Once your information is organized from least to greatest, find your median. Then we need to find our lower and upper quartile ranges. Again, that's also finding the median of that set of data. You're going to make a vertical line at the median, a vertical line at the lower quartile range and upper quartile range, and that's going to create your box. Then put your minimum and maximum and connect those boxes with a line to make your whiskers. So let's practice this. Suppose you caught 13 fish in a lake and measured each one. The lengths in inches are as follows. Okay, so they gave us this set of data, and we need to organize this data from least to greatest. All right, so your lowest number is 5, then 6, 8, 9, 9, 12, 12, 12, 13, 14, 14, 16, and 20. Now it's a very good idea to make sure that if you have 13 numbers in your original set of data, that you have 13 numbers when you rewrite it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have all of our numbers listed. So that's step 1. Then we need to find the median. Okay, so we got to find the middle number. So if we've got 13, we should have 6 numbers on either side. So 1, 2, 3, 4, 5, 6. And that's going to make us have 12 as our median. So what we're going to do is plot our median. Draw a vertical line at 12. Okay? From here, you're going to take the median of your lower set of numbers. Well, if you notice, you've got 6 numbers on either side. So we're going to take the average of the middle 2. The average of that is going to be 8.5. So we're going to draw a line at 8.5. We have to do the same thing for the upper quartile, but this math is a little bit easier. Since they're both 14, then the median is going to be 14. So we're going to take those numbers and make our box. Our minimum was 5, so we're going to take that and connect it, make our whisker. And our maximum was 20, and we're going to make our whisker on that end too. So we've just drawn our box and whisker plots. However, now we need to fill in the rest of the information. It wanted the mean, mode, range, and outlier. So again, mean is the average. Add all of those numbers together and divide by 13, and you'll get that your mean is 11.54. Your mode is the number that happens most often. Well, 12 happened 3 times, So that's going to be our mode. We don't have an outlier in this situation because there is no number that's significantly farther outside of the majority of the numbers. And then range, you take your largest number, which is 20, subtract the lowest number, which is 5, and that gives us a range of 15. You can also make a box and whisker plot on your calculator. To do this, follow the steps listed below. You're going to press your stat button and hit enter. That simply means that once you've hit enter, you're already on the category for edit, and you're going to input all of your data. After you've input all your data, you need to hit second y equals, and you're going to press enter 2 times. That's going to turn on the plot. From there, you're going to highlight the box and whisker picture. Okay? Once you've done that, hit your graph button and then press trace, and you can use your left and right arrow to scroll through and find the boundary for each point on the box and whisker plot. Okay, so let's do another example of a box and whisker plot. This time we're going to use the number of pairs of shoes that you own. So first thing we have to do is organize from least to greatest. So we have 3, 5, 5, 7, 8, 10, 15, 15, 19, 20, 26, and 28. So we've got everything in order from least to greatest. Now we are able to find our median number, okay? Well, this time we have an even set of numbers. We've got 12 numbers. So what we're going to need to do is take the average of the middle 2 numbers. Well, the average of 10 and 15 give us a median of 12 and a half. From here, we have to plot our vertical line. Now notice that this time our number line is counting by 2's. So we're not going to be quite at the halfway mark because that would be 13. So we're going to kind of make that at the quarter mark. Make your vertical line. Alright, we need to also find the median of the upper and lower set of data. So our middle number of the lower set of data is 5. So let's plot that. And then the median of our upper set of data is 20. So we'll plot that as well. And let's go ahead and make our box. Our lower range, which is 3, is our minimum. So make our whisker there. And then our upper set of data is 28. So we're going to plot that. Oops, excuse me, I made that a little long. And that's going to be our box and whisker plot. However, we still need to find the mean, mode, range, and outlier. So add up all those numbers and then divide by 12. So we get 161 divided by 12, which gives us an average of 13.42. Again, mode is the number that happens most often, and in this situation we have 2 because 5 happens 2 times and 15 also happens 2 times. We still don't have an outlier because none of the numbers in our data set is significantly larger or smaller than the majority of numbers. And then our range is 28 minus 3, which gives us a range of 25. In our third example, we've been given the ages for family members in our data set. So first thing we need to do is organize these from least to greatest. So we have 5, 12, 15, 16, 16, 16, 21, 30, 35, 42, 43, 47, 50, 50, and 54. So we need to add all of those numbers together and divide by 15 in order for us to get the average, or our mean, which gives us an average of 30.13. Our mode, our number that happens most often, is going to be 16, because that happens 3 times. But this time we do have an outlier of 5, because 5 is significantly lower than any other number in our data set. Our range is 49. Okay, so we've taken care of everything that we needed to except for our box and whisker plot. The number in the middle of our data set, so our median, is going to be 30. So let's draw a line at 30. The median of our lower set of data is 16, and it's going to be the first 16 on your number line, or on your set of data. And then also 47 is going to be the median of the upper set of data. So let's plot that down and make the box. And now we need to make our whisker. So our lowest number is 5. Our highest number is 54. So now that we've got our box and whisker plot, we're all done. We do have one more example, so let's move along to the last example. Okay, so our last box and whisker plot, we're actually comparing 2 different box and whisker plots. So in this situation, we're comparing Team 1 and Team 2. The first question is asking us, which team has the highest median? Okay, so we recognize that the median is the line in the middle of our box and whisker plot. Well, looking at those 2, which number is farther along on your number line? Well, Team 2 is. Because at Team 2, your median is 40, whereas in Team 1, your median was only 35. Then our second question, what's the difference in the box range from Team 2 to Team 1? So what we need to do in this situation is find the range in each box, okay, and then do the difference, so subtract. Well, we could do all that work, or we could just look at the picture and notice that in Team 2, our box is 5 spaces longer than in Team 1. So this is going to have a difference of 5. And then which team has the lowest range? All right, so again, for the range, you take your highest number in the data set minus the lowest number. So for Team 1, it has a range of 60. Team 2 has a range of 55. So which one has the lowest? Well, that would be team 2 because it has a range of 55.